Good day, learners. For today, let's have a new topic to discuss, and it's all about parallelogram and its properties. This is prepared by Seth Kersley May Sinangote saying, "Hello, learners." To start with, let's have first the definition of a parallelogram. What is a parallelogram? It is a quadrilateral with two pairs of parallel sides. As you can see in the illustration, we have their letters A, B, C, and D found in each of its vertices. In naming parallelograms, we say parallelogram A, B, C, D. Since it is a quadrilateral with two pairs of parallel sides, we can say that CA is parallel to DB and AB is parallel to CD. In the illustration, you can see arrows on each of the segments to symbolize their parallelism. After knowing the definition of a parallelogram, let's now proceed on discovering its properties. In a parallelogram, we can find at least 5 properties, but on some books, it only says 4. So, in this instructional video, I am going to present to you 5 properties of a parallelogram. First property states that opposite sides of a parallelogram are congruent. For example, in the illustration, you can see parallelogram ABCD. Since the theorem 1 states that opposite sides of a parallelogram are congruent, if we have segment CA is equal to 5, then by theorem 1, segment BD is also equal to 5 since the two segments are opposite. Let's have the second property. Opposite angles of a parallelogram are congruent. So what does this mean? We have here an illustration of a parallelogram ABCD. So when we say opposite angles of a parallelogram are congruent, meaning if we have angle B which measures 39 degrees, meaning the angle opposite angle B also measures 39 degrees, and the angle opposite angle B is angle C, so angle C measures 39 degrees. Let's have the third property, which says consecutive angles of a parallelogram are supplementary. First, let's have the definition of supplementary. So what does supplementary mean? Supplementary meaning the sum of the two angles is equal to 180 degrees. So for example, we have here still the illustration parallelogram ABCD. So if measure of angle B is equal to 39 degrees, by theorem 3, which states that consecutive angles of a parallelogram are supplementary, so we have angles A and B as the consecutive angle of angle B, meaning angle A measures 141 degrees and at the same time angle D also measures 141 degrees. Okay, let's now have an example for the first 3 properties. Let's say, find the values of x and y in the following figure, given that y is a parallelogram. What is the perimeter of the parallelogram? So we have here parallelogram y with angle I measuring 50 degrees. Angle W is the unknown y and angle S is the unknown x. The length of segment WI is 13 and the length of segment IE is 9. So let's see the solution. Angle S and angle I are opposite angles, and so by theorem 2, which states that opposite angles of a parallelogram are congruent, we have the measure of x is equal to 50 degrees, since angle S and angle I are opposite angles. Also, since angle W and angle S are consecutive angles by Theorem 3, which states that consecutive angles of a parallelogram are supplementary. Thus, we have the equation 180 degrees is equal to x plus y. We substitute the value of x. X is equal to 50 degrees, so we have 180 degrees is equal to 50 degrees plus y. So by subtraction property of equality, we have 180 degrees minus 50 degrees is equal to y. For simplification, we have y is equal to 130 degrees, meaning the measure of y or the measure of angle W is equal to 180 degrees. Let's now proceed to the next question, which is, what is the perimeter of the parallelogram? By Theorem 1, it says that opposite sides of a parallelogram are congruent. We see that IE is equal to 9 and WI is equal to 13, so that the perimeter of y is given by P is equal to 2 times 13 plus 2 times 9. And then we manipulate the equation, so we have 2 times 13 is equal to 26 and 2 times 9 is equal to 18, so we have P is equal to 26 plus 18. And then 26 plus 18 is equal to 44. The perimeter of parallelogram y is equal to 44. Let's have the next property. So the next property is the diagonals of a parallelogram bisect each other. Let's still have the illustration ABCD. Parallelogram ABCD has two diagonals, which are diagonal AD and diagonal BC. So when we say bisecting each other, meaning the two diagonals were equally bisected. And the result is that those diagonals that were being bisected have equal measures. Last property, Theorem 5, we have a diagonal of a parallelogram forms two congruent triangles. So in the illustration, if we have parallelogram ABCD, if one diagonal, for example diagonal AD, bisects the parallelogram, so it can provide two congruent triangles. So we have triangle ACD and triangle DBA, which are congruent. Okay, let's now have the example. Find the values of M if the measure of RP is equal to 3M and EP is equal to M plus 20. So we have their parallelogram rows and point P as the intersection of the two diagonals. Solution: by Theorem 4, which states that the diagonals of a parallelogram bisect each other, therefore we can say that 3M is equal to M plus 20. By subtraction property of equality, we have 3M minus M is equal to 20. And by division property of equality, we can have 2m is equal to 20 since 3m minus m is equal to 2m. Divide both sides by 2. We have m is equal to 10. So the length of RP is equal to 30 and the length of EP is equal to 30, meaning both segments are equal and were equally bisected. That's all for our topic for today. Thank you for watching.